Alright, now we have some problems from section 2. This really gave everybody a hard time on the test. So I'm going to go through it and try to explain it as best I can to help you understand. Remember that the perfect squares are going to be 1, 4, 9, 20, 16, I'm having trouble with my program, 16, 25, 36, 49, on and on and on. Okay, there's a whole bunch of them. The smallest one, other than 1, is 4. So I always check to see, is this divisible by 4? So 320 is divisible by 4. It's 4 times 80. Alright, now the square root of 320 is the same thing as the square root of 4 times the square root of 80. The square root of 80 is the same thing as the square root of 4 times the square root of 20. The square root of 20 is the same thing as the square root of 4 times the square root of 5. Okay? Now, I'm not going to use 320 anymore because we broke it down. I'm not going to use 80 anymore because we broke it down. I'm not going to use 20 anymore because we broke it down. So what that leaves me with is the square root of 4 times the square root of 4 times the square root of 4 times the square root of 5. Okay? So I know the square root of 4 is 2. The square root of 4 is 2. The square root of 4 is 2. So now I have 2 times 2 times 2 times the square root of 5. 2 times 2 times 2 is 8 times the square root of 5. This is completely simplified now. I have one number on the outside and one number on the inside, and that's it. So the solution for this was 8 square root of 5. For number 18, a lot of people got this problem and had no difficulty with it, but if you did have difficulty with it, look at this. I have the square root of 9 over the square root of 49. The square root of 9 is 3. The square root of 49 is 7. Once you take the square root of something, the square root symbol is gone. So the answer for this is just 3 over 7. Now, number 19. If you have a number in front, you multiply them. If you have numbers inside, you multiply them. So it's kind of like combining like terms, except for I'm multiplying like terms. The 7 and the 3 multiply to be 21. The 20 and the 10 multiply to be 200. We can do that because anything that's in a square root can go with anything that's in a square root, and the numbers that are outside can go with each other. But that's not the end of the problem. You have to break down the 200 if it'll break down. So again, I'm going to start with 4. So the square root of 4 times the square root of square root of 4 times the square root of 50. That breaks down into the square root of 25 times the square root of 2. I'm not going to break down the square root of 25 because remember my list of perfect squares? I'll list them again for you. 25 is a perfect square. When I get to a perfect square, I'm going to stop. So I've broken this down. I broke down 200, I'm not using it anymore. I broke down 50, I'm not using it anymore. So what do I have left? I have 21 times the square root of 4 times the square root of 25 times the square root of 2. 21 is a number. The square root of 4 is 2. The square root of 25 is 5. So now I have 21 times 2 times 5 times the square root of 2. So I multiplied 21 times 2 times 5, and you get 210, and then this times the square root of 2. And that's your solution. That's how that breaks down. And the last problem with the square roots before we get to the solving of square roots is this problem where we have a square root in the denominator and we don't want it. All you do is multiply by that number, top and bottom. When you multiply straight across. So this is 7 times the square root of 12, and the square root of 12 times the square root of 12 is just 12 with no square root symbol. And that's all you had to do. That's simplified. Some people did simplify further and did a really great job, but this is all you had to do. Alright, I'm skipping now to 23. When you solve anything with a square root, you have to isolate the square root part, or the perfect square part. So x minus 3 is squared. That's what we're going to isolate. So I have to subtract the 17 from both sides. So now I have x minus 3 squared equals 81. Now, we're going to square root both sides. How do you get rid of something that is squared? You square root it. Square rooting a square causes them to cancel. So x minus 3 is what's left when you take the square root of x minus 3 squared. When I take the square root of 81, I get plus or minus 9. Now, almost done, except for we have to add 3 to both sides. So x is going to be plus or minus 9 plus 3. That means two things. It's positive 9 plus 3, and it's negative 9 plus 3. So when I do my solutions, one of my solutions is 12, and one of my solutions is negative 6. A lot of people want to say plus or minus 9 plus 3 is plus or minus 12, but that's not true. See how it breaks up? So those are the two solutions. Alright, one more problem in this section. Again, what is squared? X. That's the only thing that's squared. So I have to subtract 27. Let me switch colors back. When I subtract 27, I'm going to get 3, 3, 0. I still have to get x squared by itself. Divide by 3. Divide by 3. X squared equals 110. How do I get rid of a square? You square root it. Square root, square root. Square root cancels the square. X is left, plus or minus the square root of 110. Now, I can go through the process and I can see, is 110 going to break down? But it's not divisible by 4. It's not divisible by 9, it's not divisible by 16, it's not divisible by 25. So it doesn't have any perfect squares in it. So then we can't simplify it. If we can't simplify it, then we leave it the way it is. That's an okay answer. Okay. I'm skipping 25 because it was just another let's see, it was, what was it? I think it was 5 plus 5w. It's either plus 5w or minus 5w. Yeah, it was plus. So, no, it was minus. So, when you do this, you get w minus 12, and you get w plus, oh, I messed up already. It wasn't 5 at all. This number right here was 7. So you do minus 12 and plus 5 because minus 12 and plus 5 gives you negative 7. But remember, the solutions are the opposite. W equals 12, W equals negative 5, and you had to cross this out. If you didn't cross it out, then you lost a point because you have to tell me that that does not work. You cannot have a negative width. Alright, number 26. We did a problem just like this. A lot of people remembered and did a great job. The length is 4 feet longer than the width. That means if I take the width and I add 4 feet, then I get the length. The area is 45, and I even wrote for you L times W equals your area, so L times W equals 45. If you put these two things together, 4 plus W equals L. Make a substitution. 4 plus W times W equals 45. Some people just forgot to put parentheses. Distribute your W. 4W plus W squared equals 45. Now, you can't leave the W squared over here. To be able to factor it, W squared has to be first. So you write W squared plus 4W minus 45 equals 0. From this point here, you can do W plus 9 and W minus 5, because 9 minus 5 is 4. Your solutions are the opposite. And again, you cannot have a negative width. So I know W is 5, but the problem says to find the length and the width. So telling me W is 5 is not the end. You do have to go ahead and say also L is going to be 9. A lot of people figured this out without even using any process, and that's okay, but it's very important that you understand where this came from.